Hello students, let's try to understand the measurement of the physical properties. This topic we are going to understand. Now we are how you are going to measure the physical quantity. Quantity measurement of the properties is required for the scientific investigation. Many properties of matter such as length, area, volume, etc. are quantitative in nature. Any quantitative observation or measurement is represented by the number followed by units in which it is the measured. For example, length of a room can be represented as 6 meter. Here 6 is the number and m denoted the meter, the unit in which the length is measured. Okay, so two things are required, student. Okay, that is what very important point. Wherever you are studying, student, that point you need to understand what they are saying. Quantity measurement of the properties is required for scientific investigation. Many properties of matter such as length, area, volume are quantitative in nature. Any quantitative observation or the measurement is represented by number followed by unit. So number followed by unit in which the measured. For example, length of the room can be represented by 6 meter. 6 is the number, m is the denotes the meter, the unit in which the length is measured. Earlier, two different system of the measurement in English systems and metric system were being used in different part of the world. The metric system, which originated in France in late 18th century, was more convenient as it was based on the decimal system. Late need of the common standard system was filled by the scientific community. Such a system was established in 1960 and is discussed in detail below. The International System of Unit SI. The International System of Unit SI. The International System of Units in French Lie system, International D units, abbreviated SI, was established by the 11th General Conference of the on Weights and Measured, CGPM Conference on Weight and Measures, General Conference. See, from the Conference General des Poets and Measures. The CGPM is an intergovernmental treaty organization created by diplomatic treaty known as meter conversation with sign in the Paris in 1875. The SI system has the 7 base unit and they are listed in table 1.1. These units pertain to the 7 fundamental scientific quantities. The other physical quantities such as speed, volume, density, etc. can be derived from these quantities. Now see, the length is represented by meter. Length is the physical quantity. Symbol is the L and SI unit meter, symbol M. Mass M, SI unit kilogram, that is kg. Time T, second. Electric current I, ampere A. Thermodynamic temperature T, Kelvin K. Amount of substance N, mole and mole. Luminous intensity IV, candela and CD. The definition of the SI base units are given in table 1.2. The SI system allows the use of prefix to indicate the multiple or the submultiple of a unit. These prefixes are listed in table. Let us now quickly go through some of the quantities which you will be often using in this book. Okay, length of meter. The meter symbol M is the SI units of length. It is defined by the taking the prefix numerical value of the speed of light in vacuum C to be the 299792458 when expressed in the unit meter per second, where the second is defined in term of the CGM frequency, delta VCS. Unit of mass is kilogram, unit of time is second, unit of electric current is ampere, unit of thermodynamics temperature is Kelvin, unit of amount of substance is mole, unit of luminous intensity candela. Okay, so this is what. Now uh, prefix used in the SI system. So this is the Acto Y 10 power minus 24, Gypto 10 power minus 21, R2 10 power minus 18, Femto 10 power minus 15, Pico 10 power minus 12, Nano 10 power minus 10, Micro 10, Micro 10 power minus 6, Milli 10 power minus 3, Centi 10 power minus 2, Deci 10 power minus 1, Deca 10, Hecto 100, Kilo 10 power 3, Mega 10 power minus 6, Giga 10 power 9, Tera 10 power 12, Peta 10 power 15, Ixa 10 power 18, Zeta 10 power 21, Iota 10 power 24. So these are a mass and weight. Let's try to understand mass and weight. Okay, student, mass and weight. Mass of substance is the amount of matter present in it, while weight is the force exerted by the gravity on an object. The mass of an substance is constant, whereas its weight may vary from one place to another due to the change in the gravity. You should be careful in using these terms. The mass of the substance can be determined accurately in the laboratory by using an analytical balance. The SI unit of a mass as given in the table 1.1 is kilogram. However, its fraction named as gram is used in laboratory due to the smaller amount of the chemical used in the chemical reaction. Now volume. Volume is the amount of space occupied by the substance. It has the unit of length cube. So SI system volume has unit meter cube, but again in chemistry laboratory smaller volume are used, hence volume is often denoted by centimeter cube or decimeter cube. A common unit liter, which is not an SI unit, is used for the length for the measurement of the volume of liquid. 1 liter is equal to 1000 ml or 1000 centimeter cube is equal to 1 decimeter cube. Okay, this is there. In the laboratory, the volume of liquid solution can be measured by the graduated cylinder, burette, pipette, etc. A volumetric flask is used to prepare a known volume of the solution. These measuring devices are known in figure 1.6. So pipette, burette, graduated cylinder, volumetric flask. Density. The two properties mass and volume discussed above are related as follows. Density is equal to mass by volume. Density of substance is its amount of mass per unit volume. So SI unit of density can be obtained as follows. So SI unit of density is SI unit of mass by SI unit of volume, that is kg upon meter cube or kg meter cube per cube. This unit is quite large and a chemist often express the density gram centimeter cube, gram per centimeter cube, where mass is expressed in the gram and volume is expressed in centimeter cube. Density of the substance tells us about how closely its particles are packed. If density is more, it means particles are more closely packed. Temperature. There are three common scales to measure the temperature: degree Celsius, Fahrenheit, Kelvin. Here Kelvin is the SI unit. The thermometer based on these scales are shown in figure 1.8. Generally, the thermometer with the scales are calibrated from 0 to 100 degrees Celsius, where these two temperatures are freezing point and the boiling point of the water respectively. The Fahrenheit scale is represented between the 32 degree to 212. The temperature on the scales are related to each other by following. Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. And the Kelvin scales are related to Kelvin is equal to what is going to be, student, degree Celsius plus 273.15. It is interesting to note that temperature below 0 degree is negative value or possible in Celsius scale, but at Kelvin scale negative temperature is not possible. So this is all about the point, student. Here you can say 0 degree means 273.15 Kelvin, and here is in Fahrenheit it is going to be 32. If you talk about 25 degrees Celsius, so Kelvin it is going to be the 298 and Fahrenheit 77. If it is 37 degrees Celsius, Kelvin is 310 and human body is the 98.6. At 100 degrees Celsius 373, boiling point of water 212 Fahrenheit. So this is what. In the next video we are going to understand uncertainty in measurement, student. So thank you so much for watching this video, student. Thank you so much.